Hope you all are doing well. I, Umesh Patil, welcome you all in third session of thermodynamics. In previous two sessions, we discussed about what is thermodynamics, various applications of thermodynamics in detail. Then we discuss about program outcome structure, what will be the structure of third semester in BTech in mechanical engineering. Then we discuss about the program outcomes, course outcome. Now today we'll begin this session with course structure. So totally there are 4 credits as we discussed in previous session. The course of thermodynamics, it is having 4 credits and these credits will be awarded to you through a examination scheme as per follows. So just read the slide, go through the slide, then I will explain this slide in detail. So there will be a continuous assessment. It is a part of internal assessment for 20 marks. This continuous assessment is divided into 2 parts. I hope you are well aware with this continuous assessment system. So this continuous assessment is internal assessment. It will be divided into 2 parts. First one, internal continuous assessment 1 for 10 marks, and second one, internal continuous assessment for 10 marks. So for the course of thermodynamics, in internal continuous assessment 1, you have to face a quiz. That quiz will be online. There will be 20 questions and the time limit will be 15 minutes. In 15 minutes, you have to complete the quiz, attempt the quiz, and according to the marks, according to your score, you will get a marks in continuous assessment 1. And in continuous assessment 2, you have to present a poster. You have to make a poster by using a Microsoft slide, a single slide. You have to make a poster on a topic. That particular topic is regarding with the fundamentals in thermodynamics or applications of the thermodynamics. For example, suppose one student taken topic as compressor. So you have to get a picture of the compressor either from book or from the Google or from the research paper. You can take an image of a compressor. You have to explain construction working of the compressor, and you have to write how the compressor work, and then lastly performance analysis and conclusion. So you have to make all these things in a single slide. It will be poster and you have to present that poster maybe in online mode. So that will be the internal continuous assessment second for 10 marks. Individually you have to prepare a poster. Okay, I hope this internal continuous assessment part is clear to you. I am again going to repeat it. So in first part CA1, there will be a quiz, online quiz for 10 marks. There will be 10 questions. Time limit will be 15 minutes. Okay, and in second part, internal continuous assessment 2, CA2, you have to make a poster based on fundamentals of thermodynamics or on applications of thermodynamics. You have to make a poster on a single slide and you have to present it on online mode individually. Okay, then there will be a second part, that is mid semester examination. It will be for 20 marks, and you are well aware that it will be based on first 3 unit of the course. And lastly, there will be end semester exam for 60 marks, which is conducted by the University, Dr. Babasaheb Ambedkar Technological University, Loneri will conduct this end semester examination. We are going to inform in well in advance about this end semester examination. I hope this examination scheme is clear to you. Now let's proceed towards the course content. What will be the content of the course? So this course is totally divided into 40 hours course, and total course is divided into 6 unit. First unit that we are going to start is the fundamental concepts and definition. So this unit contain all fundamentals that are needed to understand the thermodynamics and then to apply this fundamental concept to various applications for doing the thermal analysis of various thermal devices. So this fundamental concept is very, very important. As I told you previously, so if you want to make a career in any one application area of the thermodynamics, these fundamental concepts and definition, you should always remember, or you should understand all these fundamental concepts and definitions. So here in first unit, we are going to learn thermodynamic system, what is properties, point function, path function, processes and cycle, work and heat transfer, temperature and its measurement, what is temperature and how temperature is measured by using a different devices, then zeroth law of thermodynamics, and lastly specific heat. These are the content of unit number 1. Unit number 2 is based on first law of thermodynamics. So in thermodynamics we are going to learn two important law, first law of thermodynamics and second law of thermodynamics. So there will be a separate unit on each law. So first law of thermodynamics content statement of first law of thermodynamics, then first law of thermodynamics applicable to a closed system undergoing a cycle. Then from first law of thermodynamics again we come to know about the important property enthalpy, then concept of control volume, perpetual motion machine of first kind, then applications of first law of thermodynamics to various steady flow devices that we observe in day-to-day life and which is very commonly used in all type of industry. It may be a power industry, it may be automobile industry, it may be aviation industry, or even it may be a pharmaceutical industry. So some of the devices are listed here, such as nozzle, turbine, compressor, pump, boiler and throttle valve. So we are going to apply this steady flow energy equation to all these devices one by one. Then unit number 3 is based on second law of thermodynamics. So there are certain limitations of first law of thermodynamics. So second law is invented and it is purely based on concept of heat engine, refrigerator and heat pump. And there are two statements of second law of thermodynamics, Kelvin Planck and Clausius statement. At first sight, these two statements look totally different, but we'll learn these two statements are equivalent and how they are equivalent that we are going to learn here in this topic. Then concept of reversibility and irreversibility, Carnot cycle, Carnot theorem, and lastly absolute thermodynamic temperature scales. How different thermodynamic temperature scales are invented and what is the base for thermodynamic temperature scale that we are going to learn in the last topic. Now let's come to the unit number 4, which is based on entropy. Entropy is again one of the most important derived properties of any thermal system. So in that we are going to learn what introduction, what means what is entropy, what are the importance of the entropy, then Clausius theorem, then temperature entropy plot that we are going to learn, Clausius inequality, entropy and its irreversibility, entropy principle. Okay, entropy of the universe is continuously going on increasing and that is a main concern to the human. So that part we are going to learn in that topic. Then combine first and second law, entropy and direction, and lastly entropy and disorder. Now let's come to unit number 5, contents of unit number 5. So unit number 5, it is based on availability. So in availability, we are going to learn the important concept of available energy. So what do you mean by available energy and what do you mean by unavailable energy that we are going to learn in a cycle. Then quality of energy. So according to the quality of energy, there may be a high grade energy or there may be low grade energy. So here I will just give you an example of high grade energy and low grade energy. So electrical energy is considered as the high grade energy and heat is considered as the low grade energy. So we learn in this unit why electrical energy is the high grade energy and heat is the low grade energy. Then law of degradation of energy, maximum work in reversible process, dead state, availability in flow and non-flow process, and second law efficiency that we are going to evaluate in unit number 5, availability. And lastly, unit number 6, it is based on ideal gas and properties of pure substance. Can somebody tell me what is pure substance? You can unmute yourself and then reply. What do you mean by pure substance? Yes, please. What do you mean by pure substance? What is pure substance? Because complete unit is based on properties of pure substance. So we must know what is pure substance. Or can you give some example of pure substance? You can unmute yourself and then reply.
Gold metal.
Sorry. Can you please repeat?
Gold.
Gold is a pure substance. Sorry, it is not a correct answer. Somebody else? But very good. You tried. At least you tried to speak. Very good. Somebody else? Can you quote or can you put or suggest at least one example of pure substance? I think you have learned this pure substance concept in 11th or 12th standard, or maybe in first year chemistry part. Okay, doesn't matter. I'm going to tell you, pure substance means the substance whose chemical composition remains same in all the pages. We know every substance exists in 3 pages. What are that 3 pages? Student, please reply. What are the 3 phases of a fluid or a substance?
Solid, liquid, and gas.
Very good. Very good. Absolutely correct. So any substance exists in 3 phases: solid, liquid, and gases. And if the chemical composition of a particular subject remain same in all the 3 phases. Let's take example of water. What is the chemical formula of water in liquid state?
H2O.
Correct. Very good.
H2O.
Absolutely correct. H2O is the chemical formula of water in liquid state. What about gaseous state? What is the chemical formula of water in gaseous phase? Again, it is H2O, water vapors, which is called as the steam. Correct? Again, chemical formula of steam is H2O. Correct? And the solid
Yes, sir.
phase of water, is ice. Do you agree with this?
Yes, sir.
And its chemical formula is again H2O. The chemical formula of ice, water ice, is H2O. Okay. So chemical formula is same in all the 3 pages: liquid, gases, and solid. So water is a pure substance. Okay. So again, there may be carbon dioxide, CO2. Its chemical formula is same in all the 3 pages. So CO2 is again a pure substance. Okay. So we learn what are the properties of the pure substance. Why we are interested to know the properties of pure substance? The answer lies in application. Power plant. If you see power plant, thermal and nuclear power plant, what is the working substance in thermal and nuclear power plant? Somebody please reply. Which one is the working substance in thermal and nuclear power plant? Water. Water is the working substance in thermal as well as nuclear power plant. Water is converted into steam. That steam is expanded over the turbine, so we get a mechanical energy. Again, that steam is condensed in condenser, and again it is given back to the boiler or steam generator. Correct? So water is the working substance. Okay. So how much amount of power is developed by the turbine, it will be decided by the properties of the water. Do you agree with this? How much power that turbine will produce or how much electrical energy that generator will produce, it will be decided by the properties of the water. So we must know what are the properties of pure substance, which is generally water, and how, and these properties will decide how much power that turbine will produce and what will be the thermal efficiency of the turbine. So as an engineer, we must know theoretically how much power a particular turbine will produce. That is design part. So as a mechanical engineer, we are supposed to design something. We have to do modification in the existing product, or we have to develop some new products. Okay. So if you want to design a steam turbine, or if you want to measure the performance of the existing turbine, you must know the properties of the working substance. And the working substance most commonly used in power industry is the water, because water is easily available. It is free of cost. Okay. And again, heat content capacity of the water is very good, and it is a pure substance. Its chemical composition remains same in all the phases. Okay. That's why this chapter is included in your syllabus. So for unit number 6, you need to have a copy of steam table. Okay. So it is a small book. The name of the book is the steam table. You can easily get this steam table from a general stores. So you have to procure that, or I will try to get a soft copy, and that's I will share that soft copy with you. But while learning the unit number 6, steam table is mandatory, just like the log table that you use in elementary school. Okay. So steam table is must in unit number 6. So where we can read the different properties of steam at different pressure and temperature, that we are going to learn in unit number 6. I hope you are now aware with contents. Okay. These contents or syllabus is already shared with you in a channel. If some students are not knowing, if you go on a channel, thermodynamics is the name of the channel, and on file tabs you can see some contents is uploaded. So I have uploaded syllabus of the course, thermodynamics syllabus in detail, including PO, CO, examination scheme, and the content, unit wide content of the course, along with the references, that are needed, various books, that is textbooks or references, I have uploaded there in file tab. Again, I have uploaded the teaching plan for unit number 1, where you can get page number of a particular topic. So page number is given and the reference book is given. Okay. So if you want, suppose if you want to read thermodynamic system, so in that teaching plan, it is given on which page number you will get a thermodynamic system and in which book. So you will get a name of book and page number to refer or to learn a particular topic. Okay. So keep a habit of learning. Then again, I shared 2 ebooks with you: PK Nag, Engineering Thermodynamics by PK Nag, and Thermodynamics, A Classical Approach by Cengel and Bowles. These are the very good books for learning the course of thermodynamics. Again, if you go for higher education, or if you want to appear in any competitive exam related with the engineering, these 2 books are very, very important. If you are going to prepare for a GATE exam, if you want to work with some government companies, Navratna companies, where GATE is mandatory, GATE valid score is mandatory, qualifying score is mandatory. So again, if you go through the content of the course, almost these contents are there in a GATE syllabus. So you are going to appear GATE in 2023. Okay. So again, thermodynamics is one of the important course from GATE point of view. Okay. So refer the standard books. Okay. And I am going to share with you the material as and when needed. But please refer that material. It is not for me, it is for all of you. Okay. I hope you are going to refer all that material. So course contents are clear. Now let's move to the next part, references. So for learning, understanding, and applying the concepts and knowledge of thermodynamics, the important references are given over this slide. Okay. You will get these references in the syllabus. So textbook, PKNAC Engineering Thermodynamics ebook is already shared in a file tab. Then Cengel Bolt's Thermodynamics and Engineering Approach. And along with that, certain reference books are referred, Van Leeuwen and Sontag. These all books are available with me. If you are localite, you can come and consult me. I will provide you, or all these books are available in the library. You can get it from library. Now let's come to the fundamental concepts. Okay, so unit number 1 content already we discussed. Now let's come to the fundamental properties. So in elementary schooling or in 11 12, we learn certain important properties, that is pressure, volume and temperature. So these are the basic properties or fundamental properties. If you want to define any system, so it is defined by using these properties: pressure, volume and temperature. So these are the basic properties. And again, these properties are easily measured by using certain standard equipments. Okay. So you just tell me which instrument is used to measure a pressure, standard instrument or equipment. You can unmute yourself and then reply. Which instrument is used to measure pressure?
Yes,
Sorry?
sir. Pressure gauges.
Pressure gauges, absolutely correct. Very good. Pressure gauges are used. Okay. So if you see in day-to-day life, if you are feeling air in a tire of a motorcycle or car, that person, technician, is checking the pressure of air by using a certain gauge. Okay. So gauge is a standard instrument which is used to, pressure gauge is a standard instrument which is used to measure a pressure. And everywhere you will see the pressure gauges. Okay. So pressure can be measured by using a pressure gauges. What about volume? How to measure volume? What are the instruments that are used to measure the volume? Please reply. So it is a live session. It doesn't matter, but try to speak. How volume is measured? Again, in day-to-day life, we measure the volume. Volume is measured in liters. So it is measured by using a liter flask, or if a substance is filled in a particular container, and if we know the dimensions of the container, we can calculate the volume of the substance. So let's take an example of cylinder. So how the volume of cylinder is calculated? Can somebody tell? How the volume of a cylinder having a diameter D and length L is calculated? Please reply. What will be the volume of cylinder? How to calculate volume of a cylinder? Please reply. Okay, so volume of cylinder is pi by 4 d square L. Volume of cylinder, pi having a value generally as pi value is taken as 3.14. So pi by 4 into d square into L is the volume of the cylinder. So we can measure the volume of any regular body. It may be cylinder, it may be cube. So we can measure. So if you see, the fluids are generally flowing through pipes. Pipes are cylindrical in shape. Okay. So we can calculate how much amount of, if we take an example of water pipeline, how much water is flowing per unit time through a pipe by calculating the volume of the pipe. Okay. So volume is a Rushikesh, unmute yourself. So if somebody asks you how much amount of water is flowing through a pipe having diameter of 2 inch and a length of 1 meter or 5 feet, okay? So you can calculate how much amount of water is flowing through a pipe having diameter of 2 inch and length of 5 feet. So diameter square into length into pi divided by 4. So that will give the volume of water available or flowing through that pipe. Okay. And third important property is the temperature. So how temperature is measured? How temperature is measured? What are the devices that are used to measure the temperature in day-to-day life? Please reply.
Thermometer.
Students. Thermometer. Very good. Absolutely correct. Thermometer. Temperature guns. Thermocouple. These are the devices which are used to measure the temperature. So temperature measurement is easy because of these devices which are available right now. Even thermal gun, which is mandatory, as I already told you, in healthcare, thermal gun is mandatory because of the COVID situation. Then thermometers and thermocouples. Thermocouples are generally used in industries for measuring the temperature of the fluid during the operation. So thermocouples that we are going to learn here in unit number 4 in topic temperature and its measurement. Okay. So what is basically a pressure? How to define a pressure? Students, what is pressure? What is pressure? It is defined. It is in front of you. You have to only read it. What is pressure? What is pressure?
Force upon area.
Force upon area. Very good. It is mentioned over the slide. Pressure is defined as force per unit area is the pressure. If a force is applied over a particular area, then that force per unit area is pressure. So force is generally measured according to the Newton's law. Force is in Newton and area is in meter square. So Newton per meter square is the unit of pressure, which is called as the Pascal. So pressure is measured in Pascal. Okay, and higher unit of pressure is bar. 1 bar is equal to 10 raised to 5 Pascal. And you can define volume. Volume is nothing but a space occupied by a substance. Okay, so if you fill a particular fluid in a container, if it is rectangular in cylindrical in shape, then we can measure the volume of that fluid by using a formula pi by 4 d square L divided by 4, where d is the diameter of the cylinder and L is length of the cylinder. And again, 1 liter of volume is equal to 1000 centimeter cube. Okay. So in last lecture, I have given you the assignment, engine capacity in centimeter cube. Sorry to say, but only few students have submitted. Remaining, try to submit up to today evening. So in that, engine capacity is in cc. Cc means centimeter cube. So 1000 centimeter cube means 1 liter. Okay. So higher engines are generally measured in liters. So if you see the car engines, it is mentioned 1.2 liter engine, 0.8 liter engine, 1.5 liter engine, 2 liter engine, 3 liter engine. So that liter means 1 liter means 1000 cc. So 3 liter engine means it is having capacity 3000 centimeter cube. Okay. So understand these fundamental properties. What do you mean by pressure? A unit of pressure, and what are the instruments that are used to measure a pressure. Similarly, what is volume? In simple, volume is nothing but a space occupied. Okay. It is in meter cube or it may be in liter. And I have given one example here. If you want to measure the volume of a cylinder, it is pi by 4 d square L divided pi by 4 d square into L, and 1 liter is equal to 1000 centimeter. And third important fundamental property is temperature. Okay, temperature is defined as degree of hotness or coldness. It may be measured in degree Celsius, it may be measured in Fahrenheit, but the most commonly used scale is the degree Celsius or Kelvin scale, or in some cases like in healthcare, Fahrenheit scale is preferred for measuring the temperature. So these are the three important fundamental or basic property of any thermal device. Along with this, we are going to learn certain derived properties. Okay, I am just naming here the derived properties. So these three derived properties are enthalpy, entropy, and internal energy. So we are going to learn this one by one in the course of thermodynamics. But here you just understand the fundamental properties: pressure, volume, and temperature, their definitions, their unit of measurement, and the different instruments that are used to measure these fundamental properties. Okay. Now let's come to the different type of gas laws. Okay. So these three properties, pressure, volume, and temperature, they are interlinked with each other by different gas laws. So this Boyle's law is one of them, which gives relation between pressure and volume. So pressure is inversely proportional to volume if the temperature is kept constant. So this is statement of Boyle's law. Okay. So this gas law speak about relation between pressure, volume, and temperature, how they are correlated with each other. Okay. So first law is Boyle's law. Okay. So if we take pressure, volume, and temperature, if temperature is kept constant, then pressure will vary inversely with volume. It means if we increase the pressure on a fluid, its volume will decrease, and vice versa. If we reduce the pressure, the volume will increase. So this is Boyle's law. Let's see the practical application of Boyle's law. So just read this and try to understand what is written here. So Boyle's law, real life example is a Coca-Cola bottle or any cold drink bottle. Okay. So it is having that content of Coca-Cola or Pepsi, which is in which CO2 is in dissolved form. Okay. And when we open the cap of the bottle, if it slowly open, so it will suddenly increase the volume, and thereby the some amount of Pepsi or Coca-Cola will come out from the bottle, and CO2 gas will try to escape from the bottle, and thereby there is decrease in pressure of the fluid inside a bottle. Okay, so this is a real life example of Boyle's law. Okay, or you can take an example of a rubber ball. Okay, if you press the rubber ball, press means if we apply or if we increase the pressure on the rubber ball, what happens? The volume of the air inside that rubber ball will reduce, and if we release the pressure, again it will regain its original shape. So these are the real life example of Boyle's law. I hope Boyle's law is clear to you. Okay, wait a minute, just a minute, I will download the attendance. Okay, so attendance is downloaded. Can somebody tell me why attendance is low today? Hello? Hello?
Yes, sir.
Hello. Yes, sir.
Why attendance is low today? Why the number of students are less? Is there any problem?
No.
Hello? Somebody please reply. Okay, okay. We can discuss it later on. Now let's proceed towards the next law, which gives relation between pressure and volume and temperature. Okay. So before moving towards the next law, I am again going to repeat the Boyle's law, so that everybody should able to answer. Generally in interviews, the interviewer asks you about the what is Boyle's law and give some example of the Boyle's law. So Boyle's law speak about relation between pressure and volume. When temperature is kept constant, pressure is varies inversely with the volume. Means if we increase the pressure, volume will decrease, and if we decrease the pressure, the volume will increase. You can clearly observe this here on this diagram, pressure volume diagram or volume pressure diagram. Okay, so if volume is increased, the pressure will be low, and if the pressure is increased, there will be reduction in the volume, and vice versa. Okay, so if the volume is increasing, in this way the volume is increasing, so there is reduction in pressure. Okay, and again you can see here one again one image. So container fitted with a piston which is moving inside this container, and this container is filled with the gases, and if we apply pressure over this piston, the piston will move downward. Okay, so thereby the volume of gas will decrease. You can see here the volume of gas is this one, and now it reduced to almost half. If we increase from P1 to P2, and there is reduction in volume from V1 to V2. You can clearly observe here V1 is greater than V2. So what it indicates? There is reduction in the volume of a gas inside a container if we increase pressure from P1 to P2. So here P2 is greater than P1 and this V2 is less than P1. So it is Boyle's law. Okay. So I hope Boyle's law is clear to you. Now let's move to the next law, that is Charles' law. Okay. So when we discuss about the fundamental properties, pressure, volume and temperature, so we get a relation between pressure and volume from the Boyle's law. Now there is a remaining relations are relation between volume and temperature and pressure and temperature. Okay. So if you write down these three property on a plain paper, pressure, volume and temperature, so there exists a three relation between pressure and volume, second relation between volume and temperature, and third relation between pressure and temperature. So from Boyle's law we get relation between pressure and volume. Now from Charles' law we can get relation between volume and temperature. So you just read the statement of Charles' law. So according to Charles' law, the volume of a gas is directly proportional to the temperature of the gas when pressure is kept constant. Again understand here, while correlating the two fundamental properties, the third property is kept constant. So let's correlate this with Boyle's law. So in Boyle's law, while giving relation between pressure and volume, temperature is kept constant. In Charles' law, while giving relation between volume and temperature, pressure is kept constant. Okay, so pressure exerted over this piston is constant here, and the gas is heated. So as soon as the gas is as soon as we start to heat the gas, the molecule of gas will expand and it will exert pressure over this piston, and this piston will move upward as the amount of heat go on increasing. As the temperature of this gas go on increasing, the volume of gas will also increase. So this is Charles' law. So volume is directly proportional to temperature when pressure is kept constant. So again, you can observe here volume temperature graph, volume on y-axis, temperature on x-axis, and as the temperature increases, volume also increases. And in certain slope, and this slope is nothing but volume by temperature constant. If you take slope at any 2 points, we get a constant slope. Okay, that's why this is the nature of the graph will be a straight inclined line having fixed slope, and the slope is given by volume by temperature. So this is Charles' law, and the example, most important example of Charles' law is the hot air balloon. Do you know how hot air balloon works? Can somebody tell me how the hot air balloon works? And you can read the sentences written over this slide for a minute. Then I will explain how this hot air balloon works. Just read carefully. And this hot air balloon works on Charles' law. Okay. Just read this sentence and correlate this sentence with the statement of Charles' law. So statement of Charles' law is volume is directly proportional to temperature if the pressure is kept constant. Okay. So here in hot air balloon, the pressure is kept constant at atmospheric pressure. Okay, the value of atmospheric pressure at sea level is 1.01325 bar. So pressure is kept constant at this pressure at this level, and if we start the burner of the hot air balloon, so whatever air is present in the balloon, it will start to get heated, and as soon as the gas start to heat, particularly the gas is air. So as soon as air is heated, as we know, hot air is lighter in weight than the cold air. So this hot air will upward direction. Okay. So this hot air will carry balloon along with the basket in upward direction. Okay. So this volume of this balloon will decide how much weight that basket can carry. Means how many persons that basket can take into at certain height. That will be decided by the volume of the balloon. Larger the volume of the balloon, more will be the air inside a balloon, and more will be the hot air, and this hot air will carry that balloon in a atmosphere. So this hot air balloon works according to the Charles' law of thermodynamics. So I hope Boyle's law and Charles' law is clear to you. In next session, we'll discuss about the Gay-Lucas law of thermodynamics, which gives relation between pressure and temperature by keeping volume constant. Okay. Bye, student. Have a good day. We'll meet in next session. Thank you.